Howdy folks, Mr. Reed here, and welcome to One More Question. So for today, what we're going to take a look at is just a graph where we're doing either a vertical or a horizontal transformation, and the second graph is already present. So what we're going to do is write an algebraic form to represent what kind of transformation has happened. This is going to be a mild level of question, so let's get to it. All right, so as you can see, we have the question above us is basically just to do the transformation. We have our graphs sitting over there, I believe, and we're going to do this by looking at an important point on one, or I guess the original graph, and seeing where that maps on the second graph. So if I said that this point right here was an important point, what I mean by that is it's a recognizable point that I'm not going to get confused for a different point in the second graph. So it is the, I guess, the edge or the end point, or first end point of this particular f of x function. Any of those four that are marked off on the graph would be pretty reasonable. There is a difference between, for instance, these first two, the one that I just circled and the next one, and these two over here, in that you can tell the slope between those consecutive points is different. It's much steeper at the beginning than at the to the left than it is for the 2 points that are to the right instead. So what we're going to do is just take that one that I did circle earlier, and we're going to see where that same point shows up in the new transformed g of x function. So if I go down to the g of x function, we'll note that this thing right here is the same point. Now, all we're going to do is do a quick skim and say, okay, well, that thing has moved then 1, 2, 3, 4 units down, and that's all there is to it. So 4 units down is, for us, we'd like to describe g of x as a transformation of f of x, and if you followed along with the stuff earlier, you'll know that generally this is taken care of by the k parameter, which is at the end. And 4 down is the same thing as the k parameter being -4. So we're going to add -4 onto this, which is the same thing as just putting -4 at the end. Oh, silly little thing is not going to... There we go. Sorry about that. All right. So the idea here is that we have basically moved down 4 units, and that's what we end up with. Now, I do have a second one that's going to do horizontal instead of vertical. So 1, 2, 3, here we go. All right. Now, the idea here is that we have 2 graphs again. F of x is going to be our original. G of x is the next graph. Now, the g of x graph, again, if we choose an important point, I'm going to choose a different one. Just for the sake of doing something a little bit different this time, I'm going to choose one that's an interior point. So it's the one that is on the steep pair of consecutive ones. Later on, this is going to become more important, so you might wonder why I'm saying things like this. For the time being, we don't have any flips or reflections going on, so the order of the points is fairly obvious for us at this moment. Later on, that may not be the case, so that's why I'm being a little more careful in the way that I'm talking about it. Next up, we identify which of these points is going to be the associated one in the next function, which is the one that I circled there on the g of x function. That point is 1, 2, 3, 4, 5 units to the right. Now, just like last time, we are going to describe g of x as a transformation of the f of x function. That works by using the h parameter, and that h parameter is x minus h inside of the argument is where that's located. We want this thing to move 5 units to the right. So 5 units to the right is a +5 for the h parameter, which means it's x minus +5, or just x minus 5 is the way that we can put that. Again, because our h parameter was a +5 in this particular case. All right, so that's how we take 2 graphs and be able to do a transformation that's specifically a translation. Basically, we're counting spaces, and if you can count the number of spaces that you have to move, probably the hardest thing is just making sure you know which one's the original function and which one is the transformed version. So once you know which direction you're going, count left, right, up, down, and you'll have it. So hopefully that was helpful to you. Again, if you would like to like and subscribe, that would be helpful to me. And if you have some comments, please get in touch. Take care, folks.